Hello class 12 students. Today we will study derivation for calculating energy density of a capacitor. Energy density means what? Like mass density. Mass density means mass by volume. Similarly, energy density means energy by volume. So in particular volume, how much energy is one capacitor is storing, for that formula we derive this derivation. For this energy stored in capacitor, first already we had studied in the earlier lecture, U is the energy stored half Q square by C. This formula yesterday we have seen, and one more and capacitance formula C epsilon naught A by D, that also we had derived. So this one we mark as first equation, this we mark as second equation. All these formulas we had already learned. You should go through and revise it. Now charge equal to surface charge density into area. That formula you are knowing, surface charge density is equal to charge by area. From that formula you are getting this expression. Now sigma is how much? E epsilon naught in the region between the plates of capacitor. इनफाइनाइट प्लेट्स हैं तो वहाँ पे ये फॉर्मूला रहेगा ई इक्वल टू एप्सिलॉन नॉट सिग्मा बाय एप्सिलॉन नॉट. फ्रॉम दैट वी आर गिविंग सिग्मा इज इक्वल टू ई एप्सिलॉन नॉट. ई एप्सिलॉन नॉट ए, we put value of sigma here, there's E epsilon naught A. Now Q will be equal to E is the electric field, epsilon naught A. This will be given as third equation. Now substitute value of Q and C in first equation. We will get energy stored as E square. So in this expression you will get. From this expression you will see one epsilon naught will cancel out, A cancel out, this D will go upstairs and this will become AD. One A will remain, one epsilon naught will remain. Then this expression will become half E square epsilon naught AD. AD आपको मालूम है area into distance, that will be volume between the plates where the electric field exists. So this will be volume. So when it will go down cross multiplication, U by AD equal to half E square epsilon naught. This is the expression for energy density, energy stored per unit volume. This is the final formula, that is energy density equal to U equal to energy density, you are denoting U here, half E square epsilon naught. Epsilon naught is a constant, so energy stored per unit volume is proportional to electric field E square. Next we will study capacitors in series. We are studying capacitors in series and capacitors in parallel. This is very important in case of numericals, like you had studied in resistors in series and resistors in parallel. Now it's very easy. You see we are taking three capacitors C1, C2, C3 in parallel. In series connection, charge will be same, voltage will distributed V1, V2, V3. Total voltage will be V equal to V1 plus V2 plus V3. And in overall voltage, effective voltage will be V equal to Q by CS, where CS is the equivalent capacitance of three capacitors. So each V1 will be equal to Q by C1, V2 is equal to Q by C2, you can see here, and V3 equal to Q by C3. These all expressions we will put in the first equation. This equation we will put and you will get this expression as Q by CS equal to Q by C1 plus Q by C2 plus Q by C3. From here we will get common Q and this Q will get cancel out, and final expression is 1 by CS equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the effective capacitance in case of series capacitors. Next, if n capacitors you will take, then this expression will become up to 1 by Cn. Next is capacitors in parallel. Same method you have to use, but in capacitors voltage will be constant and charge will get distributed. So charge will be equal to Q equal to Q1 plus Q2 plus Q3. In Q formula we are knowing CV, so parallel combination equivalent capacitance will be Cp. Q1 is C1V, Q2 is C2V, Q3 is C3V, all we will put here, and your final expression will be CPV equal to C1V plus C2V plus C3V. V get common out and cancelled out on both sides, and final expression is Cp equal to C1 plus C2 plus C3. In capacitors, if n capacitors we are taken, then this will be the final expression, Cp equal to C1 plus C2 plus C3 up to Cn. Thank you.